Accelerometer. This sensor measures force and movement across three directions simultaneously. When a phone is picked up, tilted, or shaken, the accelerometer registers that motion and passes the data to whatever app needs it. Screen rotation relies on it. Step counting relies on it. Even the way some phones wake up when lifted from a table traces back to this single component working quietly in the background. Gyroscope. Movement and rotation are two different things, and the gyroscope handles rotation. It tracks how the device spins and tilts with a precision that goes beyond what the accelerometer alone can provide. Mobile gaming benefits from this when physical tilting controls direction, and video recording depends on it to feed stabilization systems that reduce the effect of hand movement while filming. Ambient Light Sensor. This sensor reads the brightness of the surrounding environment continuously. Based on what it detects, the display adjusts its own brightness automatically without any input from the user. A dim room brings the screen down. Strong sunlight pushes it higher. The adjustment happens smoothly and constantly, balancing visibility with power consumption throughout the day. Proximity sensor. When a phone is brought close to the face during a call, the screen turns off. That response comes from the sensor. It emits a small infrared beam and detects how quickly it reflects back, determining whether an object is nearby. On phones without a visible front bezel, the same function is achieved through software processing or sensors embedded beneath the display glass. Magnetometer. The Earth produces a natural magnetic field, and this sensor reads it. That is what allows a phone to function as a compass and orient a map correctly based on the direction the device is facing. Navigation apps depend on it to point the user in the right direction, and augmented reality applications use it to understand the physical orientation of the camera relative to the world around it. Barometer. Atmospheric pressure changes with altitude, and this sensor measures those changes. Navigation apps use that information to determine whether a person is at street level or on an elevated floor of a building. Fitness applications read it to count flights of stairs. The data it provides adds a layer of spatial awareness that GPS coordinates alone cannot fully capture. GPS receiver. This sensor connects to satellites orbiting the Earth and uses the timing of their signals to calculate the phone's position on the surface. Multiple satellite signals arrive at slightly different times, and the receiver uses those differences to triangulate location. To improve speed and accuracy, phones combine satellite data with nearby Wi-Fi networks and cell tower signals, which allows location to be established faster and maintained in environments where satellite signals are partially blocked. Fingerprint Sensor. This sensor captures the unique pattern of ridges on a fingertip and matches it against a stored reference to confirm identity. Budget and mid-range phones typically place it on the side frame or the back panel. Higher-end devices embed it beneath the display, either using light to image the fingerprint through the glass or using sound waves to physically map the ridge structure of the finger. Both approaches work without requiring any visible button or cutout. Face recognition sensor. The front-facing camera combined with dedicated processing software handles face unlock on most devices. More secure implementations go further by projecting infrared light or structured dot patterns onto the face and reading how those patterns deform across its surface. This builds a three-dimensional model that is considerably harder to deceive than a system based on a flat camera image alone. LiDAR Scanner. This sensor emits rapid pulses of laser light and measures the time each pulse takes to return after bouncing off a surface. By doing this thousands of times per second, it constructs a detailed depth map of the space in front of the camera. That depth information improves autofocus performance in low light, refines the separation between subject and background in portrait photography, and allows augmented reality content to interact accurately with real physical surfaces.